The Global Research and Education Network. What is it? I mean, I know, and you probably know, but how do you explain it to somebody else? We've all done it. Wouldn't a picture help to show the scope and reach? Many maps have been made for just this reason. Most of them took a long time and a lot of painstaking effort to make, and they're beautiful. And they are now, as we speak, either out of date or will be soon. How about one that stays up to date? And while we're at it, how about one that's zoom and pannable and interactive? How about one that can be altered to show various perspectives and support different messages? Challenge accepted. Hi, my name is Ryan Davies. I'm a software developer at Canary and co-chair of the Gren Map working group, alongside Tom Fryer from Géant. I'm here with Dan.
Hi, I'm Dan Sellers, manager of the software development team at Canary.
And on behalf of the Gren Map working group, a global collaboration, we're here to introduce you to the Gren Map project. The Gren Map working group is guiding the development of a unified system for visualizing the high-level connectivity of and participation in the community of research and education networks around the globe, the GREN. The system, as an interactive, tangible representation of the GREN, will support robust discussions of the GREN's value propositions with government, researchers, and connected institutions. The goal of this working group is to achieve a dynamic, interactive visualization of the GREN that is perpetually up to date, without requiring onerous parallel data collection and maintenance activities. This is supported by the joint development of a reference data model and data maintenance and automation tools. And the visualization may serve as a reference for other renderings created by the community in order to apply different aesthetics or perspectives on the same source data. Under the guidance of the working group, the software development team devised a system to meet those objectives. The system involves three main components: a distributed database to store and manage the network mapping data, a format for import, export, and interchange between the nodes in the distributed database, and a reference visualization to view data in the database to draw a dynamic, interactive map. The primary innovation in the system is that it places responsibility on each research and education network, or REN, large and small, to maintain their own data and federates that data into a global database. Maps can then draw from this global database as their data source, and the community can produce maps of any description based on this data. Each node in this distributed database is a set of Docker containers that can be hosted by the REN or deployed in the cloud. The software allows network engineers to insert and update their data. Once data for a REN is inserted into the system, it will be shared hierarchically from smaller to larger RENs until it reaches a central node for the entire GREN. This sharing, secured by encryption and a private key to verify provenance, will be set up to occur on a regular schedule. When data from multiple sources are combined through this distributed system, there will inevitably be duplicates and conflicts and varying conventions. It will fall on the larger interconnecting RENs, such as at the national and continental levels, not to mention the global level, to resolve these situations. While data administrators can easily fix these issues through the user interface, the real problem is that in order for the whole database to remain up to date, the data will be shared at regular intervals, and any fixes would likely be overwritten each time a sharing cycle occurs. Give a database a fish and it'll eat for a day. Teach a database to fish and it'll eat forever. We've introduced the concept of a rule. A rule combines the logic to identify when situations occur and the resolution to the situation. Data administrators can set up these parameters and expect the rules to apply the same logic every time the data is merged. For all this sharing between remote database nodes, we needed to define a common data format. Network Markup Language, or NML, is an XML-based format that fit many of our needs. However, it was a bit cumbersome, as it was designed for low-level connectivity description, while our needs are higher level, and tool support was also a bit lacking. We based a new format called GrenML or GrenML on NML and built a suite of tools around it, including a Python library installable via pip, a spreadsheet template for entering data, and a conversion script to turn that spreadsheet data into GrenML. Of course, each database node uses GrenML to import data in bulk to initially enter each REN's network mapping data, to update it, and to share between database nodes in the hierarchy we described a few minutes ago. And, of course, what everyone surely wants to see is all that great data being put to use to draw a map. The open source leaflet library is being leveraged to allow us to build dynamic, interactive map views.
Here we can see further details about a map node as supplied by GrenML. We can see information about the managing organizations and the managing organizations of directly connected nodes, along with metadata such as tags. We can also see additional information about links. As with nodes, we see the managing organizations and the tag metadata. We also get to see the nodes connected to each end of this link. The map can zoom to show a view of the whole REN. Here we have Red Clara, RMP, Riuna, and CDO. I can then click on an SREN, a subnational network, and show BCNet in Canada. Finally, selecting on a PREN, I get to show the whole of Norginet and its reach. Here is a feature currently in development, which allows us to filter by tags. Here I have filtered to an international node. Then I also select the SRENs, and finally the NREN nodes, and we bring all the nodes back to the map. This will soon be expanded to cover additional properties and links.
We've started with just these basic features, and we look forward to building out the visualization with richer features as the project gains momentum. For this initiative to really work, we need to achieve a critical mass of participation. It seems the interest in the community is strong. We've already had over 20 early adopter RENs submit their data into this system. We have released a sandbox version of the distributed database software for the purpose of independent evaluation locally, to provide feedback to the working group and as a way to help get your data into the GrenML format. We've also deployed beta instances of the software across cloud environments and host machines used in today's demo. Here's what it looked like as we brought database nodes for several early participant RENs online.
Hi Joe, thanks for joining us.
Yeah, not a problem. Thanks for having me.
Okay, so what we want to do here is onboard your data onto the Canary node. So if you could generate a token and pass it over to us, then I will add it into our node.
Sure, let me do that right now. All right, so adding a token. And I've got my token here, and so I'll send it to you.
Yeah, excellent. Over the chat would be great. Thank you.
Yep.
Great, I've got that. Okay, I've got that. I'm just going to save that and test the connection. Okay, we've got a successful ping on that. I'm now going to go and have a look at the polling logs to see if we've got a poll. Okay, we've got a successful poll here. So let's go and refresh the map, and we should see the Cyber data appear on the Canary map.
Great.
All right, I've logged in, so now I'm going to upload our data from a spreadsheet, import files. So now I'm going to go to the map and have a look. Oh, hey, there's our data. Very nice. There's my token.
Excellent, thank you. I'm just going to copy that token. We'll view the map on the Gren node. And we can see the Giant data is now added to the global view.
Terrific.
Thank you very much, guys.
Brilliant.
That's our pleasure.
That's
Good to see it
quite
on a
easy.
global scale.
Gustavo, thank you very much for joining us from RMP to onboard your data into our Gren node.
To create the token, we have to access the tokens menu. Now I'm adding a new token. We have to give the token a name. I'm calling Gren. And now we have the token. I will send to you then.
Great, thank you very much. If we now go and look at the map and refresh the map, we can see the new data from South America appear.
You're welcome.
A public version 1.0 release is being prepared now for release very soon. We're hoping that, eventually, every Wren will download and install a copy of the software once it's released, and participate in the distributed Gren Map database. But don't wait. You can get your data into the Gren Map today. It can be as simple as filling in a spreadsheet template we've prepared and sending it to us. Can you think of a feature you'd like to see? Let us know, or better yet, contribute to the project. As an open source project, we welcome development collaborations, or join the working group. Thanks for your attention. Really quickly, I'd like to take this moment to thank everyone in the working group. Also, software development contributors Canary, RNP, and Géant, and all data contributors for bringing us this far with the project. We are proud of what we've accomplished, and we look forward to the public release soon. If you have any questions, we are more than happy to answer them now.